Okay, class, Dr. Barnes here. Let's take a look still on the properties of Fourier transforms. So this is part 4. Okay, so here we're going to see number 9, which is the duality property. Okay, so if you have a Fourier, a signal such that it has a Fourier transform of x of omega, okay, then you're going to have, in terms of the duality, x of t is going to be Fourier transform of 2 pi into x of minus negative omega. Okay, so how do we prove this? We use the inverse, because of this 2 pi here, use the inverse Fourier transform approach. So here you're going to have, with the inverse Fourier transform, you're going to have x of t is equals to 1 over 2 pi into minus infinity to what? Infinity. Okay, and then you're going to have x of what? Omega. X of omega into e minus j omega t d omega. Okay, so this is what we're going to have. Okay, so now here we will substitute t equals negative t. Okay, t is equals to negative t. So in that case, I'll have what? I'll have x of minus t. Okay, x of minus t is equals to 1 over what? 2 pi into integral of minus infinity and then what? Infinity. Okay, x of omega into e minus j omega t d omega. The omega. So now what we do is that we interchange t by omega. Okay, in that case I'm going to have x of what? Minus omega here is equals to 1 of what? 2 pi infinity minus infinity. Okay, x of what? T. Okay, x of t into e minus j what? T d what? T. Okay, so this is what I'm going to have here. Now, from here, I can bring this one here, and I'll have what? 2 pi x of minus what? Omega. Okay, is equals to integral infinity minus infinity. X of what? T. E minus j omega t the what? The t. Okay, so now when I have this one, what I can say is that what I can see from here is that this expression I have here is what? It's Fourier transform, which gives you x of what? Omega. And x of omega is the Fourier transform of what? X of t. So this function I have here is x of omega, because it's the Fourier transform of x of t, which gives x of omega. So this one is x of omega. And x of omega is the Fourier transform of what? Of x of t. So instead of writing x of omega, I can write x of what? T. Okay, which is the Fourier what? Transform. Okay, which is the Fourier transform of what? 2 pi into 2 pi x into minus what? Omega. Okay, and so now what this one means, I can just reverse it. X of what? T is the what? Fourier what? Transform of what? 2 pi x of what? Minus what? Omega. So this is the what? The duality property. Alright, so let's go to the next property. So we shall go on to property number 10. Okay, and that is the time reversal property. Okay, time reversal property. So let me write here number 10. Time reversal property. So is the time reversal what? Property. So what is that time reversal property? If we have x of t, okay, and is the Fourier transform giving minus x of what? Omega. Then, okay, here if, okay, then x of what? Minus t is the Fourier transform of x of minus what? Omega. Alright, so how can we prove this one? We will use inverse Fourier transform. Okay, so the inverse Fourier transform of x of t is 1 over what? 2 pi into what? Minus infinity to what? Infinity. Okay, x of what? Omega into what? E minus j omega what? T the what? The omega. Okay, so here replace t by minus t. Okay, so in that case, I'll get what? I'm going to have x of what? Minus t is equals to x of minus t is equals to 1 over what? 2 pi integral minus infinity. Here is what? Infinity. Okay, x of what? Omega. E minus j omega what? T the what? The omega. Okay, so when I have here, substitute w by what? Minus w. Okay, so now when I have this one, then I will have what? X of what? Minus t is equals to 1 over what? 2 pi integral infinity minus infinity, x of what? Minus omega into e minus j what? T. Okay, minus j omega t the what? The omega. Okay, the omega. Alright, so now when I have that, then what it actually means is that, you see this particular function I have, basically it's x of t, because it's the Fourier transform that gives us x of t. But s of t is the Fourier transform of what? X of what? Omega. So instead of writing s of t, I can write x of omega, because x of t is the same thing as what? X of omega, because x of what? The Fourier transform of x of omega is x of what? T. Okay, so I can say that x of what? Minus t, okay, here, Fourier or transform into x of what? Minus omega. Okay, so this is the what? Time reversal property. Okay, now let's go to the last what? Property for this particular section. So that is the conjugate. Okay, that is the conjugate symmetry. Symmetry property. And that is my property number what? 11. Okay, so here, if x of what? T is the Fourier transform of x of what? Omega. Okay, then I'm going to have x of complex t. Okay, x of complex conjugate t. Okay, is going to be the Fourier transform of x of what? Complex conjugate what? Omega. Okay, all right, but it's going to be minus. Okay, so it's going to be minus. Okay, so let me write it. X of complex conjugate t is the Fourier transform, okay, of x of complex conjugate what? Minus omega. So let's see how we can use prove this one. Okay, so here what we will use is that just use the inverse Fourier transform. Okay, then if you're using the inverse Fourier transform, then we know that x of t is equals to 1 over pi. Here is minus what? Infinity. Here is what? Infinity. Okay, x of what? Omega. E minus j omega what? T the what? The omega. Okay, so now we take complex conjugate of both sides. Complex conjugate of what? Both sides. So now here 1 over what? 2 pi integral minus what? Infinity what? Infinity. X of what? Here complex conjugate, alright? Okay, so just take the complex conjugate of that place, and you're going to get to minus j omega what? T the what? The omega. So now here, what we're going to now do is that you can just substitute omega into minus omega. Okay, so let's say that substitute omega by what? Minus omega. So I'll get x of what? Complex conjugate t, okay, is equals to 1 over what? 2 pi into what? Minus infinity into what? Infinity. X of what? Complex conjugate what? Minus omega. Okay, what's the substitution? E minus j omega t the what? The omega. Okay, so now we can see that this function I have here is what? The inverse Fourier transform of x of t. But x of t is the what? Is also the Fourier transform of what? X of omega. So in that case, instead of x of omega, I can write instead of writing x of t, I can write x of omega. So the complex conjugate of x of t, okay, will give us a Fourier transform of x of what? Complex conjugate minus what? Omega. All right. So this brings us to this question. Let's see you in the next session. Thank you.